Okay, here is the Chapter 1 review, problem number 13. The first question asks, what is the average, what are these, weight or something? Gosh, let me get the book. What is the average mass? That's right. What is the average mass of all three particles? Giving your answer in standard form to three significant figures. Okay, so we have three different masses. We're just going to add them together. I'm not going to write them all out again. I'm just going to use N, P, and E. So we're going to do, for part A, we're going to do N plus P plus E and divide it all by 3 because it's the average or the mean. So one thing is, how do you put these into your calculator? You can just type them in 1.675 times 10 to the negative 27th. You can do it like that, but, oh man, we're going to have this problem again, aren't we? Shoo, come on. Come on. Let me see it. Oh, this is killing me. I still haven't figured this out. Okay, so you can do it like that, or there is another way. Let me clear that out. Let's see if I can help this out. The other way is you can use this EE button, which is above the comma. So I posted a video showing you how to do this in great detail. But you can also do entering scientific notation this other way, which is, again, we start with 1.675. And then to get the scientific notation that a calculator shows, you do second comma. Let's see if it's showing up. That gets you that capital letter E. Let's see if I can get it going this way. Capital letter E, and then you just type the exponent, so negative 27. Okay, so I'm going to enter in the next one, which would be 1.673, second comma, negative 27, plus 9.109, second key comma, negative 31. Okay, so that gets me all three of them entered in scientific notation. I'm going to hit enter and then divide by 3. To get my mean, and it spits it out in scientific notation. If we want three significant figures, it's going to be 1.12 times 10 to the negative 27th. Okay, so this would give me 1.12 times 10 to the negative 27. So notice I did not write down the letter E with a negative 27. That is only for calculators. Do not write that on a math paper. We write it out with the times 10 notation is the way that we should be doing it. All right, so that's part A. Okay, part B, they want you to write a ratio of the electron mass to neutron mass and give it in the form 1 to x. So this is the electron mass, and this is going to be the neutron mass. So I can set up a proportion to help me solve this. I can say, I'm going to set this up as a fraction. Instead of as colons, I'm going to write 1 over x. So that's 1 electron over however many neutrons is going to be the same as the mass of an electron, 9.109 times 10 to the negative 31, all divided by the mass of a neutron, which is 1.675 times 10 to the negative 27th. Okay, so when you see a ratio written like that, you can change it to 1 over that. Okay, so here's electron over neutron. Electron over neutron, electron over neutron, electron over neutron. All right, and now we're going to solve for x. Okay, so ignore that. I'm going to solve for x. I'm going to multiply both sides by 1.675 and multiply both sides by x to get rid of my fractions. So I'm going to have 1.675 times 10 to the negative 27th is equal to 9.109 times 10 to the negative 31st x. Okay, so I'm multiplying both sides by x, bringing the x over here, and multiplying both sides by 1.675 times 10 to the negative 27th, and it comes over here, also known as cross multiplying. Now to get the x by itself, I'm going to divide both sides of the equation by this coefficient of x, 9.109 times 10 to the negative 31. Same thing over here, 9.109 times 10 to the negative 31. Okay, now we're going to do that on our graphing calculator. And I'm going to do it using my scientific notation on here. So let's do 1.675 second comma negative 27. So that gets me my scientific notation. So the calculator knows that that's just one number. So I don't really have to worry about order of operations. Divided by 9.109 second comma negative 31. And hit enter, and I get 1838.84. But remember, they want everything in 3 significant figures. So the 3 significant figures would be 1840. Okay, I'm going to round that 38 to a 40. So I only have 3 significant figures. So if I write that down, I get x is equal to 1840. Okay, that's part B. And then part C, it says something about percent error in the mass if we assume the electron to be, so what if we say the electron is 1 times 10 to the negative 30th, whereas in our table it said that an electron, the mass was equal to 9.109 times 10 to the negative 31. So basically what they're doing is they're saying, well, what if we rounded this 9 off to a 10? They're taking this, they're rounding it off to, instead of 9, they're rounding it up to 10 times 10 to the 31st. But notice that's not scientific notation, because scientific notation, this number has to be between 1 and 10. It can't be 10. So if I move my decimal place over one place to the left, oops, sorry, that was a negative 31. If I move my decimal over, then it's less of a big number. That's the same as 1 times 10 to the negative 30th. Okay, so that's where they got this from. So they're saying if you take this and you round it off to this, what is your percent error? So our percent error is you take the difference of these two numbers minus 9.109 times 10 to the negative 31st, and you divide it by the actual, the more accurate measurement, which is the 9.109 times 10 to the negative 31st. And you take the absolute value of that. We don't care which one you subtract first. We're looking for a percent error. Okay, this is going to give us a decimal answer. So again, let's put that into our calculator. I'm going to do 1 second comma negative 30 minus 9.109 second comma negative 31. I'm going to go ahead and get that answer. And now I'm going to divide it by 9.109 second comma negative 31. And enter. And I get that decimal. That's my decimal answer, but they want it as a percent. So if I change that to a percent, I times it by 100. To change a decimal to a percent, you times by 100, and I get 9.78% as 3 sig figs. So this one ends up being 9.78%. That's my percentage error. So if I were to round it off, I'm making about a 10% error to the measurement by rounding it off. So that's it, problem 3. And let's stop this video.